something surprising was discovered on the far side of the moon.
For a long time, the moon was seen as an immobile and lifeless world, a celestial body that had been dry, cold, and geologically dead for billions of years.
The samples brought back by the Apollo and Soviet missions reinforced this idea: little or no water, volcanic activity that ended more than 3 billion years ago, and a practically inert surface. But recent Chinese missions under the Chang'e program have completely changed this view, revealing that the moon is, in fact, a dynamic place, with active water cycles, valuable resources, and even a more recent volcanic history than previously imagined. The Chang'e program was planned in clear and successful steps. First came the Chang'e 1 and 2 orbital probes, which mapped the surface in detail and chose the best landing sites. Then, the Chang'e 3 and 4 missions took rovers to the surface. The Jade rabbit tested how to survive the long lunar night, and Chang'e 4 made history by landing on the far side of the moon in 2019, where it managed to grow plants and communicate with Earth via a relay satellite. Finally, the Chang'e 5 and 6 missions brought samples back to Earth, something no country had done since 1976. One of the big surprises came from the Chang'e 5 samples. Tiny glass spheres formed by micrometeorite impacts function as true batteries for the solar wind. Protons coming from the sun are deposited in these glasses and combine with oxygen, creating water or hydroxyl molecules, with temperature variations throughout the lunar day. This water is released in the form of vapor and then recaptured, forming a constant cycle. Calculations indicate that there could be up to 270 billion tons of water in the moon's surface layer, enough to be extracted simply by heating the soil, without relying solely on dark craters at the poles.
Another impressive discovery was the hydrated mineral called ULM1, discovered in 2024 in samples from Chang'e 5. It is a crystal that contains up to 41% water trapped in its structure, stable even in areas illuminated by intense sunlight, far from shadowed regions. In addition to water, this mineral provides nitrogen, which can be used as fertilizer or rocket fuel. This shows that the moon stores water in unexpected places, opening doors to support future bases. Even more intriguing was the discovery of graphene and natural graphite in lunar soil. These carbon materials, which normally require complex industrial processes on Earth, arose naturally on the moon through iron-catalyzed reactions during ancient volcanic eruptions. With the help of the solar wind, this presence of exotic carbon challenges the theory that the moon is poor in volatile elements and suggests that we can use these materials to build structures or produce chemicals directly there. The Chang'e 6 mission, which collected samples from the other side, in the immense South Pole Aitken Basin, brought back even more evidence. Dated rocks show that lunar volcanism remained active until about 2.8 billion years ago, much later than previous models predicted. Even with a thicker crust on the far side, the moon's interior maintained enough heat for prolonged eruptions. All these discoveries strengthen the International Lunar Station (ILRS) project, a permanent base planned by China in partnership with other countries, including Russia. The idea is to use local resources, water from minerals and glass spheres, helium-3 for future nuclear fusion, graphene for construction materials, to create a sustainable presence on the moon, without relying so much on supplies brought from Earth.
The next steps have already been defined. Chang'e 7 will map the poles in search of ice in permanently shadowed craters, and Chang'e 8 will test 3D printing of structures using the lunar soil itself. Little by little, the moon stops being just a distant object and becomes an active world full of potential, where space exploration can become something practical and lasting. What was once considered an inhospitable desert is now revealing resources that could change the future of humanity in space.